All right, guys. So we are going to detour just a little bit from systems for today, and we're going to talk about inequalities. Okay. More importantly, the graphs of inequalities. Uh, and so when we look at equations, right, and we want everything to be in a slope-intercept form, the same is going to be true for inequalities. All right. So this is going to be Unit 5, linear inequalities. All right. So a couple things to remember, right? It's needs to be in y equals mx plus b, but we know, right, if it's an inequality, right, that is not going to be there, right? It's not going to be equal to. Solutions yield all ordered pairs. Okay. Solutions yield all ordered pairs. That will make this inequality true. So there's not just one x, y value that we're looking for. And so we need to know a couple things about, right, the solutions that are being represented. All right. And it has to do with the symbols, right? So if you recall inequality symbols, so we're going to go symbols. Okay. The symbols for an inequality are as follows. And these are my guys, right? So we've got the open closed circle that should come back to us from Unit 1. But then, we have to add to that. He's got the parentheses, right? And he's got the brackets. And so the last thing is their head. He's got a dotted line. He's got a straight hairline, right? So we've got our inequality symbols, our guys. And so we need to focus on graphing, these according to and using the dotted or solid line. And it has to do with the same, open closed circle. If it can be equal to, then it can be on the line. If it cannot be equal to, right, if it has to be greater or less than, then we have to go right up to the line. We can't actually touch the line. And so let's just look at some examples, and we'll talk about how we're going to represent these. So example number 1. Okay. And again, these are just linear inequalities. We're not trying to solve a system yet. That's coming. So less than 15. So already, before I even go through the process of trying to graph this one, I know it's going to be a dotted line, okay, because of that symbol. That symbol does not gain an equal sign somehow, some way along the way. All right. So as before, we need to switch this over to slope intercept, right? So step 1, right? Switch to slope intercept. All right. So step 1, switch to slope intercept. Well, that's going to be easy for me because again, I've done enough of this manipulation that I know I'm going to pump that negative, that 2x over to the other side, creating a negative 2x plus 15, right? So 2x just went from one side of the inequality to the other. And when it happens, it just switches value. Now, this is important, right? You have to remember anytime, right? This is the number 1 rule with inequalities. Any time we multiply or divide by a negative. The inequality symbol flips. All right, that's very important. If you don't do that, you're going to end up shading in the wrong direction. Okay, so I need to divide everything by -3 here. And what's going to happen is there's going to be a change, right? So this is going to go that way now instead of, right? So -2 divided by -3 is positive 2/3. 15 divided by -3 is -5. Okay, so I'm going to highlight that, that happened, right? By doing that for us. That happened, right? We divided by -3, so everything had to flip over. All right, so now we're ready to graph, okay? We're gonna graph it just like it was a linear equation, but we're gonna have some additional steps here, okay? So we're gonna have the same graph. All right, got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. Got a -5 as my y-intercept. So 1, 2, 3, 4, 5. Right. There's one right there. I'm going to go up 2/3. It's going to be my next point. I can do it again. So up 2/3. We'll call that 1, 2, 3. That looks good. Now, here's the important part. 1, all right? I know this is a dashed line, okay, which tells me that, right, I have to be off the line. I can't be on the line. The line is not part of the solution. So we're going to have a dashed setup between the dots. So it's kind of like our barrier, right? It's an imaginary line there that we cannot cross. Okay. Now, that means, right, anywhere greater than the line is going to be where my solution set lies. All right. So in the event of a linear equation, we've got greater, where y's are greater than the line. This side of your equation is representing your line, right? And this side is representing a value. So where the values are greater than the line, well, the y values greater than the line are the ones going up, right? So greater means we're talking about these y values, right? So all we do is look at the axis. If you look at the axis, the y-axis, you can see, right, where to go. If it was a less than, right, we'd be going down here, because we're really just talking about this one point where we're greater or less. And so what happens is our solution set becomes, right, everywhere on the graph where y values are greater than the line. And so what I usually tell my students, if you'll just shade perpendicular, okay, so at a 90-degree angle-ish to the line, you'll see your solution set. Because once we get multiple lines on here, you're going to see that's what a system is. And so you'll be able to see your shading. So you can see here, right, I've got all of the shaded region up here above the line. And as long as I stick to that region, anywhere in that region, I've got a solution. Okay, so 0, 0 should be a solution for me, right? The origin is a solution. And a lot of times I tell my students, just, hey, check that one point, right? 0, 0 is easy, super easy to check and see if it's true, right? So I go to the original, 2 times 0 is 0, 3 times 0 is 0. Is 0 less than 15? Yes, right? So this point right in here should be part of my solution set. If it's outside, then it shouldn't work. So looking at the line itself, right? These 3 points that I graphed, they're on the line, Okay, so they should not work. So let's take this one, for example. This is -3, +3. And so if I do that, right, so I've got +3, -3 as a point. That is 6. And then I've also got -3. So 6 plus 9, which is 15. 15 is not less than 15. Okay. And so that's why, right, anywhere on the line is not going to work. Right. So that would be the graph of my inequality. All right. So just a couple more, and we can just see, this is how it's done for the one. All right, let's look at let's look at a different, easier one, right? It's not so much work to do here. So example 2, y equals, or y is, less than or equal to, right? Y is less than or equal to -2x minus 1. All right, so it's already in slope-intercept form. No need to switch it. All I need to do is graph it and shade it accordingly. All right, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, doesn't have to be perfect. Y-intercept of -1, going to go down 2 over 1 for my next dot, down 2 over 1 for my next dot. And so this one, right, I know it's going to be a solid line, which means all of those points should work, okay? Because my solutions can be on the line, right? So a solid line means those solutions can exist. Now, the question is, the y's, where are they less than this line? And again, we just kind of look at the axis itself, right? So the axis itself tells me that the y's are less than down here. Okay, so I should be shading all of this region over here. Again, just going kind of perpendicular to my line for my shading. You can get as fancy as you want with it, but you don't have to. Okay. Now, again, just like I said before, the origin is a really easy point to test. So as long as your line doesn't go through the origin, it would tell you. So this one says, if I try the origin, right, it should not work, and which tells me my shading is correct, right? So just trying that one point real quick, 0, 0. If I put 0 in here and 0 in here, is 0 less than or equal to, and that goes away, -1? And the answer is no, right? 0 is greater than -1. So I know I've shaded correctly. That means that point is not part of the solution. Okay. Not much more to do on the linear inequality side of things, right? It's all about just making sure that we're in slope-intercept form, that we're graphing it correctly, and that we apply our knowledge of symbols, right? So all the things that go along with a greater than or less than is, the dotted line, the parentheses, the open circle, and then, of course, that it's shaded correctly, whether it's up or down. Make sure, guys, that we are focusing here. Okay, this is a big part of inequalities. Anytime you deal with an inequality, this is kind of the one and only rule that you must follow when you're algebraically manipulating them. And a lot of times that's the one that they're really testing you on. Okay, and a question is whether or not you're going to do that. And so it's not so much about the shading or the line or any of that. It's, did you flip it? Did you flip it when you multiply or divide by a negative? Okay, so really pay attention to that as we go along. Okay, any questions, comments, concerns, guys? Let me know. I'll get back with you as quick as I can. Thanks, guys.